Hi everyone, so today I'm here with a new problem which is shortest unsorted continuous array. So this is a lead code day 3 medium problem and we are going through this flow in order to understand this problem. So let's get started. So first of all we have to understand the problem statement. So the problem statement is we have given an array which is nums and we need to find one continuous sub array. Okay, so continuous sub array that if you only sort that sub array in ascending order, the whole array is getting sorted. Okay, and we have to return the length of that shortest sub array. Okay, what is the problem basically? Let's understand through with the help of one example. Okay, so as you see, this is one array, and here we have to find the shortest continuous sub array, means part of this array which is unsorted. Okay, such that if we sort that part, the whole array is getting sorted. If you can see here, from there we have 2. Okay, and then it is 6 and then it is 4. Now in sortedness property of array, when we move from left to right, the values should increase, but you can see when we move from 6 to 4, the value is going to decrease. It means it is not sorted. Similarly, if we see from the last, the value is 15, and we know when we move from right to left, the value is going to decrease. So now 15 to 9 value is decreased, 9 to 10 the value is increased. So it means from there the value is also not sorted. So this is the part. Okay, this one is the continuous sub array of this array, and if we sort this part, the whole array is getting sorted. And how many elements? It is 1 2 3 4 5. So it is 5 elements, right? So we need to sort these 5 elements, and that's how we are sorting our whole array. Okay, now let's come to the approach first. Okay, so let's come to the approach 1. Okay, so as I tell you, what the problem is asking. Problem is asking to find the shortest continuous part which is unsorted. Okay, it means we need to find the part where the sortedness property is violated. Okay, what is sortedness property? So sortedness property is when we move from start or left to right, the value is going to be increase. Okay, and when we move from right to left, the value is going to be decrease. Right, the same you can see from the above the value is going to decrease, and from start the value is going to be increase. Okay, so what we can do in the approach 1, we can use an stack. Okay, so we will use a stack. Okay, and we basically iterate from left to right. So basically we iterate from left to right. So 2 is there, so that is fine, and we will try to make this stack value increasing fashion. Why? Because from left to start the value is going to increase. So when we have 6, we will check 6 is greater than 2, we push it. Then we check 4, 4 is greater than 6, no. It means this is the point where it violates the property of sortedness, right? So if we take indexing 0, 1, 2, 3, 4, 5 and 6, so we can store the index let's suppose start, and the index value is 2. So this is the first point where it basically violates the condition, right? Similarly, we have what we can do, we can move from end to start. Okay, so let's take the array, and let's we are here, and let's add 15 first, and then we are adding 9. Okay, now what we want when we move from right to left, we want the value is going to be decrease, right? So when we add 10, we will check if 10 is less than 9. No, it is greater than that. So this is the next part where it violates the condition, right? Where it violates the condition. So in that case, the end is basically this. This is the index where it violates. Okay, like it basically need to be 9, but it is 10. So whatever the index, which is 4, we are going to add 1, and this is 5. Okay. Similarly, if you can see this part from the like this is the index, right? When we try to add, it violates the condition. It means the previous element makes a wrong thing here. Okay, and when we try to add 10, so it violates the condition. It means the 9, the fifth, is the element which makes uh, problem in it. So what we do, so whatever the element, like whatever the index value which is start, which is 2, what we can do, we can minus 1 from it. Why? Because the previous element is the element which violates the condition. And similarly, we have 4 here, and it violates the condition due to its next element. So we increment it by 1, which is 5. So now we have start value as 1 and end value as 5. Now we can minus 5 minus 1, which is 4, and add 1. So whatever the value we are getting, it is the length, which is from 6 to 9, and that's how we are getting the length of the continuous unsorted part of the array. I hope this part is clear to you. Okay, but what is the time and space complexity here? If we see the time complexity, so we basically write it from there to there, and then also from right to left. Okay, so at the end of the day, it is big O of n, right? And if we talk about the space complexity, in the worst case, let's suppose all the arrays are sorted. Okay, so 1 2 3 4, so everything is going to be pushed inside the stack, right? In that case, the time space complexity is big O of n. Okay, now we need to optimize it and reduce the space complexity by big O of 1. Okay, and that is where our tips comes in. So whenever we try to solve any problem, first try to solve it using brute force. Okay, if you are a beginner, solve it using brute force is a very good way. Why? Because it actually helps to understand most of the concepts. As in this problem, we are using this stack in order to solve our problem. But if we see very closely, we can find one thing, which is we actually don't need this stack. What we are doing, we at the end we are saving these indexes, right? And we basically do comparison. That's why we are saving this element. But we can do it without using the stack. Okay, how we can do this? Let's look into it. Okay, let's take the example. Let me make it down. Okay, and let's see, whenever we are using the stack, let's see how we can solve it without stack. The approach, the intuition, everything is same, only we just eliminate the stack and use some variables to solve this problem. So as we know, when we move from left to right, what we are going to check, we know everything is going to be increase, but in the starting part, or from left to right iteration, there is some value which should be small value, but due to unsortedness property we get something which is large. Okay, what I mean by this, let's understand. I'm saying that we know that, let's suppose this is 2, right? We actually know next value is going to be increase. Okay, yes, it is increase, but whatever the element which is present at this index, the next element should increase, right? But you can see the next element we find is decrease one, is decreasing. So basically this is a violates condition. This is a violates or a unhappy condition for us, and we can simply use a variable to do it. How we can do this? Let's get understand. So we basically, when we iterate from left to right, we basically store the maximum element. Okay, and we will check if there is one element which is decrease. What do you mean by this? Let's suppose I said, okay, this is the maximum element till now, right? And we will iterate, right? And at some point we will see, we if we see at some point of time there is one more element which is less than whatever the maximum element we encounter, then we can say this is the violates condition. Okay, let's go through the one iteration and you get it. Okay, see, so what I said that I will say, okay, this is the 2 is the maximum element till now I find. Then I go next and I will see, okay, 6. So 6 is greater than 2, it means, okay, 6 is the greater element, and it actually follows the sortedness property, right? Because the value should increase. Now when we go next, we see 4. So before that we encounter some maximum value and we want more maximum value after that, but we are getting the minimum value, right? In that case it is a violate condition, 0, 1 and 2. In that case we basically store this index at some point, let's suppose 2. Similarly we can go through and get the element. Okay, now we go here and you can find this is 8. So we will meditate, then we find it is 10 and we made it 10, then we find it is 9. Now this is also one violates condition. So 0, 1, 2, then 3, 4, 5 and 6. So we basically store 5 here, right? So this is the element which is violating our condition. Okay, similarly what we do is we basically iterate from last to end. Okay, and what we want, we basically want the element should decrease. So we will say this one is the minimum element till now. Okay, we assume that 15 is the minimum element till now, right? And what we want every element should decrease, should less than that, right? So we will check 9 is less than 15. Yes, it is not violating the condition. 10 is less than 9. No, it is greater than that. So it violates the condition. So we will store the index which is 4. Let's go. 8. So 8 violates the condition. Yes. No, 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 no. 8 is less than 9, right? So we can simply update it by 8. Now we will see 4. 4 is less than 8. Yes. Now we can see 6. So 6 is less than 4. No. So this is the violates condition. So index is 1. Similarly, we go next 2. So 2 is less than 4. Yes, we will update it. And then we are out of bound. So you can see by using these two variables, we can store the we can store the maximum element, and in further we will check if it is follow if it follows the sortedness property, and similarly for this, right? If it works, we are getting these two indexes, and at the end we have can say start minus end plus 1, which is 5 minus 4 plus 1, which is sorry, and is 1. So 5 minus 1 is 4 plus 1, which is 5, and that is the answer, right? So this is about the problem. Now let's see the code so that we can understand it more. Okay, so you can see here that we are considering the maximum element and we are considering the minimum element, right? And this is from left to right iteration. Okay, let me write it. So this is from left to right iteration, and this one uh, is from right to left iteration, and we basically check if there is some element which is less than that. So what we need from left to right, we need value should increase, but it is violating the condition, so we encounter it and save it, that index. And similarly, when we move from right to left, the value should decrease, but if some value is increased, right, then we save that index value, and at the end we will return it. Okay, so this works, totally works. Okay, and thank you, have a nice day.